At the beginning of military operations on the Eastern Front, amidst intensive use of artillery, engineers decided to utilize railway infrastructure for military purposes. The idea was put forward to create armored trains, mobile combat units equipped with artillery and machine guns, capable of rapid movement and supporting ground forces. The emergence of the first armored railway vehicle, protected by metal sheets and propelled by a steam engine, marked an evolution in military technology. Development began in August 1914 near Tarnopol. The 9th Railway Battalion of the Russian Empire, previously involved in track repair, received an order to create an armored train. In the absence of blueprints and ready-made solutions, driven by military necessities, an Austrian locomotive was modified within several weeks. It was sheathed with steel plates, and mountain cannons and machine guns were mounted on its platforms. Thus, the first armored train was created. Its construction was massive, and its armor, although not designed to withstand direct hits from large caliber shells, provided protection against small arms fire and shrapnel, which offered new tactical opportunities for the troops. The first combat deployment of the train, under conditions of narrow track sections, crossfire, and enemy artillery shelling, demonstrated its resilience. Despite the armor vibrating from cannon fire, the train continued to operate. Its effectiveness was noted by the command, and the term armored train entered military lexicon. This success led to an understanding of the potential of this new type of weapon. In early 1915, a second armored train appeared, which had been captured from Austro-Hungarian forces near Przemysl. Engineers restored it, reinforcing its protection and armament. Subsequently, under the command of Lieutenant Andreev, it was deployed in combat, supporting an infantry attack. Its weaponry maintained continuous fire on enemy fortifications. After this battle, the armored train received the unofficial nickname Russian Beast. These two trains served as prototypes for further developments. At the headquarters of the Southwestern Front, a decision was made regarding the necessity of supplying each army with armored trains. Development work was entrusted to officers and engineers of the Kiev Railway workshops. Project deadlines were tight, 16 days for the creation of each unit. Materials were supplied from warehouses, artillery pieces were dismantled from old fortresses, and design blueprints were developed directly on site. Work proceeded around the clock. By September 1915, 4 armored trains were ready. Their armor bore the inscriptions Khunkhuzy. This name was linked to the history of railway workers' service in the Far East, where they participated in armed clashes with militant groups. Each Khunkhuzy-type train included 2 armored carriages and a locomotive sheathed with steel plates up to 16 millimeters thick. Each carriage was equipped with a 76 millimeter cannon and 12 Schwarzlose machine guns captured from the enemy. These armored trains were characterized by their massive size and high visibility in motion, but they were protected against small arms fire. The armed forces of the Russian Empire for the first time put into operation a mobile artillery platform capable of firing upon enemy positions and then withdrawing before the start of return fire. The first combat deployment of the Khunkhuzy armored train was recorded on September 24, 1915. The commander of the train was Lieutenant Krapivnikov. At dawn, the train began to move, breaking through the first line of Austrian trenches. Artillery fired upon enemy positions, while infantry units moved behind the armored train. The locomotive operated under increased load amidst smoky conditions. After the armored train stopped under intense artillery fire, Krapivnikov gave the order to continue firing until ammunition was exhausted. Within 40 minutes, 73 artillery shells were fired and 60,000 rounds of ammunition were expended. The commander and several artillerymen perished, yet the train maintained its position. Enemy forces were repelled. Information about the armored train's effectiveness quickly spread along the front. Following the aforementioned incident, discussions began within staff structures regarding the creation of standardized models. Engineers Kublov and Pilsudski were brought in for the work. They developed new armor plating schemes and turret installations for artillery pieces. Their design solutions demonstrated advanced characteristics for that period. For the first time, revolving turrets and internal passages designed for crews were integrated. The production of these trains was not carried out in a makeshift manner, but based on thoroughly developed projects. Production work at the Kiev workshops was continuous. By the end of the year, the armed forces of the Russian Empire possessed 14 armored trains. These units were used on various sections of the front, from the Carpathians to the Caucasus. In areas where they were deployed, opposing forces suffered significant losses. According to officers, the appearance of armored trains contributed to raising the morale of military personnel, while observers from the opposing side recorded instances of panic in their units. On railways, the use of armored trains allowed for a transition from defensive to offensive operations. Along with successful operations, losses were also recorded. One armored train of the Khunkhuzy type was destroyed by a direct hit from a shell. Another train derailed as a result of shelling. Nevertheless, the aforementioned losses did not affect the overall assessment of armored train effectiveness, and their further deployment was deemed expedient. As a result, this type of weapon became one of the factors influencing the outcome of combat operations on land fronts. When the Kiev workshops began the task of constructing new armored trains, a significant number of models demonstrating a high level of engineering potential were created within a few months. The city of Kiev, being the center of the southwestern front, became a key point for the development and production of armored trains, where military engineers, blacksmiths, and railway specialists conducted intensive work on creating new weaponry for the Army. Production of these armored trains was carried out on the territory of the Kiev main railway workshops. After completion of work, they were dispatched to the front line within several weeks. Major General Georgy Kublov supervised the work. Under the leadership of this person, officers of the 2nd Overseas Railway Battalion worked who had previously served in the Far East and guarded the Chinese Eastern Railway. Their experience was recognized as key. The lack of time for experiments was dictated by the immediate necessity of supplying the front with combat-ready equipment. Staff Captain Pilsudski, a designer who developed a project combining strength and mobility, was appointed to assist Kublov. He proposed a solution involving the placement of artillery pieces in revolving turrets instead of fixed casemates. This ensured firing upon targets across a full sector, which gave the armored train the functions of a mobile artillery battery. The first armored train, designed by Pilsudski, was built in early 1916. Its hull consisted of thick, rolled steel with additional wooden layers designed to absorb impacts. Each combat platform was equipped with one 76mm cannon and several machine guns. The locomotive had a protective design that allowed the engineer to service the boiler without going outside. Observers, maintaining telephone communication with the turrets, were located in a narrow corridor between the armor and the firebox. This solution was considered advanced for that period of time. Other armored trains, developed according to General Kublov's design, were characterized by greater simplicity and high reliability. They were produced in Kiev workshops with significant speed, 16 days from the start of construction to their introduction for testing. Such production rates were among the highest for that period of time. 4 trains, built in September 1915, received the collective name Khunkhuzy. Despite the loss of one of them in battle, the other three continued to operate and gained wide recognition both among their own troops and among enemy forces. An armored train armed with two 76mm cannons and 12 Schwarzlos machine guns gained particular renown. Its crew consisted of 24 men, predominantly former railway workers, who were well acquainted with the technical structure of the train. Lieutenant Mikhailov, who displayed considerable self-control, commanded the train. In one of the battles in the Brody area, his armored train provided cover for the retreat of Russian troops. When enemy forces attempted to outflank the positions, Mikhailov gave the order for steam to be applied and, without stopping the train, opened fire on the trenches. Within half an hour, the train inflicted significant damage on the enemy's front line, which allowed the infantry units to retreat in an organized manner. The officer was awarded the St. George's Cross, and his armored train gained fame on the front. During that period, Kyiv engineers conducted tests of various designs installed on rail platforms. Various types of armor, suspension schemes, and turret shapes underwent testing in field conditions. Officers of railway units remained on the platforms for extended periods, compiling reports after each shelling. The reports contained information of this type: "The side withstood a direct hit, the crew is alive," or "The armor is penetrated, the locomotive mechanism is not damaged." This data was used as the basis for new designs. In the spring of 1916, armored trains were used in several directions. In the southern sector, in Galicia, Staff Captain Pilsudski's train provided cover for the crossing over the Dniester River. When enemy artillery opened fire, the armored train took up a position, absorbed the fire, and diverted the enemy's attention, which allowed the sappers to restore the bridge. For 2 hours, the train held its defense, conducting crossfire from 2 turrets. As a result of the incident, 3 crew members perished. The crossing was successfully completed, and the troops were able to ford the river. On the Western Front, in the Lodz area, another armored train, built by the 4th Railway Battalion, was in operation. Its design was simpler. This train was the first to employ a night raid. In November 1914, moving in complete darkness, it approached an enemy station and opened fire from a distance of less than 1 kilometer. After 30 minutes of fighting, the station was engulfed in fire, the tracks were destroyed, and enemy forces retreated in disarray. This episode was recorded in the reports of the General Staff and demonstrated the capabilities of armored trains for delivering sudden strikes. By the end of the war, the railway battalions of the Russian Empire had acquired the status of a key component of the armed forces. The operation of each armored train was ensured by engineers, master craftsmen, and artillerymen. Their activities were not always widely publicized. However, these specialists contributed to the creation of equipment distinguished by advanced engineering solutions. According to archival data, by the end of 1917, there were more than 40 armored trains of various types in the Army, and the number of personnel involved with them exceeded 130,000 people. The main period of active deployment of these armored trains coincided with the final months of the Empire's existence. With the onset of revolutionary events, armored trains were used as means of maintaining order. The period of non-use of their armament was brief. Soon, the same trains, originally created for the Imperial Army, were deployed in new conflicts, which determined their continued operation. Upon the Military Communications Command Staff's familiarization with the sketch of a new armored carriage, the project was perceived as a significant step forward in the development of railway military equipment. It represented not an ordinary train with armored platforms, but a self-propelled combat railway unit, equipped with internal combustion engines. It was capable of moving in both directions at the same speed and had a streamlined body resembling a steel boat. Colonel Butuzov's project envisioned the creation of a mobile fortress, the use of which would not be accompanied by the formation of smoke and the noise of a steam locomotive, which would preclude premature detection of its position. The decision to build was made promptly. Despite initial proposals for the production of several dozen units, it was decided to limit production to one experimental prototype, maximally improved. Work began immediately in Odessa, where a team of officers and technicians from the Trans-Amur Railway Brigade was formed. In the initial stage, difficulties arose with individual components. An order for a reverse gearbox was placed at the Putilov factory, which led to a delay in supplies for several months. Subsequently, it was determined that standard wheel pairs could not withstand the weight of the armored hull. To solve this problem, work was carried out to reinforce them, select appropriate springs, and replace hubs which ensured stable movement on the rails. Nevertheless, the project gradually moved towards completion. By the autumn of 1916, the armored vehicle was ready for testing. The design included two domed turrets with 57 mm cannons, providing an elevation angle of up to 60 degrees, intended for engaging balloons and low-flying aircraft. 8 machine guns, located in the central casemate and the front end, two 60-horsepower gasoline engines each, a duplicated control system, voice tubes, electrical signaling, and internal telephone communication. This allowed the crew to fight from within and the commander to issue orders without the need to raise his voice due to noise. The operating instructions recommended tactics including covert deployment to a position at dusk, conducting brief artillery preparation, rapid position changes, and repeated strikes until enemy batteries were suppressed. Initial tests confirmed the effectiveness of the concept. Unlike steam locomotives, which could be detected by a column of steam, the new vehicle allowed for covert approach to a position and withdrawal before the enemy had time to aim. However, in the conditions of trench warfare, which dominated the fronts of that time, the potential of this motorized armored carriage was only partially realized. In the spring of the following year, after a summer offensive that failed to achieve its objectives, the defensive line was breached, a disorganized retreat began, and railway services organized defense using available means. An armored train belonging to the 2nd Siberian Battalion, covering the retreat, encountered a damaged section of track and remained on station tracks under fire. Subsequently, it was captured by the opposing side as a trophy. During the same period, it was proposed to assemble a strike railway detachment comprising a motor car in the center, several armored draisines on the sides, and armored cars for reconnaissance in front. The proposal was sent for approval, and the coordination process began, but revolutionary events interrupted the project at an early stage. In autumn, when General Annenkoff's train was being transferred from the southwest to the north, political instability reached a significant scale. On the Nikolaevskaya Railway, echelons of the Baltic Fleet under the command of Fyodor Raskolnikov were moving towards Moscow, and an armored train traveling in transit was identified as an enemy force. The railway switches were turned to a siding, and the train was diverted onto a secondary line towards Velikie Luki. The train's crew lost cohesion and dispersed, as a result of which a detachment of sailors captured the trophy without organized resistance. Within a few days, the armored train with a new crew arrived in Moscow. There it was repaired and modernized. Cannons were replaced with standard 3-inch ones. Maxim machine guns were installed, after which the train was sent south, where it took part in military operations near Belgorod, blocking retreating units of the opposing side at railway junctions. In the spring of the following year, an order was received for its deployment to support Red Guard formations in Finland. The armored train was sent to the northwest, but Finnish railway lines were not designed for such a mass. On certain sections, it was necessary to move at an extremely low speed. In some places, the train was towed by 2 locomotives, and sometimes part of the wagons had to be left beyond dangerous bridges. Nevertheless, the armored train managed to engage in combat, but units of the Finnish national forces, having blown up the tracks, cut off its possibility of retreat. The crew abandoned the train. The locomotive was soon decommissioned due to incompatibility with local railway networks, and the armored platforms were handed over to various new owners. They were rearmed multiple times, changed owners, and continued to be operated until a new major conflict, where Finnish forces used these heavy platforms under different conditions and against other opposing sides. One such streamlined carriage, produced in Kiev in 1915, can be seen today in Parola, representing an artifact of an era when engineering thought developed solutions in the field of railway armored vehicles. In parallel, the story of the Trans-Amur armored train unfolded, assembled during the imperial period and nicknamed after the brigade. It served in the southwest. Then, during a period of political disintegration, it ended up on the Odessa tracks and soon departed far to the east. When a new conflict erupted on the Volga and in the Urals, the train, already with a different crew and a different name, was dispatched across all of Siberia. Its power, thoughtful placement of weapons, ammunition supply, and survivability were noted even by the opposing sides. In the hands of Czechoslovak units, it received the name Orlik and proceeded along the Trans-Siberian Railway from Simbirsk to Vladivostok. The further fate of the train is not documented. Documents from that time are fragmented. Therefore, it is currently not possible to definitively establish exactly where this train was transferred or used after its far eastern months. The concept of a heavy, well-protected train equipped with standard artillery pieces and a reliable communication system demonstrated its viability in protracted military conflicts. By the end of this period, a clear conclusion was drawn. An armored train without a permanent and trained crew represented merely a static asset. In cases where armed forces viewed armored trains as an auxiliary means, temporarily attached to railway units, their potential was realized only episodically. The emergence of qualified artillery commanders, technical specialists, engineers, and signalmen, along with the systematic collection of data on combat application results and the implementation of technical improvements, significantly increased the effectiveness of these machines. In areas where a disciplined crew operated, an armored train could significantly influence the course of local combat operations. In situations where it was perceived as a temporary reinforcement, its application was often limited to a single raid. This logic became fundamental in the subsequent months, when various armies began forming specialized armored units and manufacturing enterprises shifted from creating individual prototypes to serial production. A new historical period was dawning. Instead of episodic clashes with border fortifications and artillery batteries, a large-scale, countrywide war of echelons emerged, in which the armored train played the role not of a random element, but of a key support on entire fronts. During this period, individuals such as Stepan Stepanov, Fyodor Alyabiev, and numerous nameless engineers demonstrated the maximum capabilities of rail-based armored platforms, operated by professionals and maintained by highly qualified personnel responsible for every detail and every shot. The Civil War marked a new stage in the development of armored trains. What was perceived as an auxiliary means during the First World War now became the main striking force. Amidst fragmented fronts and the absence of continuous defensive lines, railways acquired strategic importance as key communications. Control over railway tracks often meant control over territory. In this context, armored trains became a central instrument of warfare, demonstrating a combination of technical equipment, organization, and firepower. The experience of the first months after the revolutionary events showed the impossibility of holding large transport hubs without heavy mobile artillery. In the south, in the vicinity of Tsaritsyn, armored trains served as a key element in the city's defense. During the offensive of the Don Cossack formations and Denikin's volunteer army in the direction of the Volga River, it was the railway battalions that ensured an organized defense. The command of the armored train column was carried out by Fyodor Alyabyev, an officer with significant experience. Under his command, 15 trains operated whose names were widely known at the front: Zaamurets, Taganrogsky, Bryansky, Volya, Molnia, named after Stalin, Communist, Third International. Each train had its own crew, individual characteristics, as well as documented successes and incurred losses. In August 1918, when parts of the White Army approached the outskirts of the city, armored trains successfully counteracted the assault. During the retreat of infantry units, armored trains maneuvered between stations along a radial network of railway tracks, firing upon the advancing forces. The scale of fire caused vibrations in buildings, and the ground surface in front of the city was pockmarked with shell craters. In one report, the defense commander indicated that the situation was restored exclusively thanks to armored trains. 2 months later, the attack was repeated, this time with the participation of the volunteer army. However, even then, the armored trains were able to hold positions, maintaining crossfire, changing deployment areas, and preventing the enemy from consolidating. As a result of these events, the term Tsaritsyn type emerged, a designation for trains characterized by a powerful casemate occupying 2/3 of the platform's length and a cannon mounted in an open position at the front. Losses were significant, but the effectiveness of their use also proved to be high. Armored trains functioned as mobile artillery batteries, as assault groups, and in some cases as the last line of defense. Among the command, the opinion took root that the presence of an armored train in a position was a key factor for holding the front. Alyabyev died in the summer of 1919. His train was surrounded, and Alyabyev was killed on the armored platform. Subsequently, his name was given to an armored train training regiment. Under conditions where hostilities continued near Tsaritsyn, the Sormovo, Izhora, and Bryansk factories began actively ramping up the production of armored trains. Early, non-standardized designs began to be replaced by serial models. In Sormovo, where river vessels and steam locomotives had previously been produced, the manufacture of standard heavy armored trains was established. Each such train included an armored steam locomotive and 2 platforms with turrets, equipped with 76mm cannons and Maxim machine guns. The armor thickness was up to 12mm. Armor plates made of special Kulibaksky plant steel were hardened and laid in 2 layers with an air gap. This design provided protection not only against bullets, but also against close shell bursts. The ammunition load exceeded 1,200 shells and 60,000 cartridges, essentially constituting a mobile artillery battery. Production was carried out under difficult conditions, characterized by shortages of fuel, metal, and labor. A report from the Sormovo factory recorded that after holidays, up to half of the workers did not report for shifts due to a lack of food. Despite this, the factory produced up to 6 armored trains per month, which was a high indicator. Similar conditions were observed at the Izhora factory in Petrograd, where lighter armored trains with a central casemate and anti-aircraft mounts were developed. These trains did not possess full armor, but were distinguished by increased maneuverability and the ability to operate on railway lines with limited carrying capacity. Separately, the work at the Dnieper factory in Kamenskoye, Kamenka, should be noted. According to engineer Klebnikov's project, 2 unique armored trains were built there. Soviet Russia and Soviet Ukraine. They were characterized by the presence of cylindrical turrets and a combination of 76 mm and 107 mm Callum cannons. The armor thickness reached 24 mm, which increased their resistance to field artillery fire. With a weight exceeding 80 tons, these trains maintained mobility and could perform maneuvers inaccessible to lighter armored trains. The Bryansk plant served as an assembly center where components were delivered. Blanks from Kamenskoye, Kamenka, armored hulls from southern regions, and armaments from arsenals. The management was carried out by Konstantin Sirkin, an engineer with profound knowledge in armored train design. According to his reports, over 1,500 people worked at the enterprise, but the work was hindered by a shortage of skilled personnel and regular interruptions in food supply. Nevertheless, the plant built 15 armored trains, most of which were immediately sent to the front. Simultaneously with production, work on standardization was underway. From the spring of 1919, armored trains were divided into light and heavy. Light ones were distinguished by speed and were equipped with one cannon and machine guns, while heavy ones represented full-fledged artillery batteries on rails. Subsequently, a new classification was introduced, which included field assault armored trains, fire support trains, and special purpose trains armed with naval guns of up to 152 mm caliber. Combat operations using these means were conducted in all directions. The southern front, where 53 armored trains were located in the autumn of 1919, became a site of intense combat operations against Wrangel's forces. In the northwest, near Petrograd, 7 armored trains confronted Udinich's troops. Various sides of the conflict, Polish formations, the White Army, interventional forces, used their own armored vehicles. Armored trains were used for fire support. They approached within direct firing range, carrying out massive shelling. When the enemy attempted to outflank positions, armored trains maneuvered along adjacent railway lines to strike at the rear. In one engagement near Popasnaya, the armored train Ugolekop entered combat with 3 British Mk5 tanks, destroying one of them with a direct hit. After this incident, the White Army Command issued an order advising against tanks approaching railway tracks. Tactical experience was formed during these battles. Positions for inspectors of armored forces were established in the main military directorate and for inspectors of field armored trains at front headquarters. Training depots were put into operation in Bryansk and Nizhny Novgorod. This marked the emergence of a centralized armored train management system, covering stages from design to operation. These combat units ceased to be episodic participants in conflicts, transforming into integral parts of combat crews with permanent personnel, established discipline, and developed application tactics. As conflicts escalated, the methods of conducting them became more complex. Armored trains began to perform not only infantry escort tasks, but also conduct independent operations, including breaking through enemy defensive lines, raids on railway stations, destroying tracks, and rapid retreat under the cover of darkness. The effectiveness of armored trains during combat operations had a significant impact on the outcome of engagements. The sound of artillery emanating from the rails often preceded a swift resolution of the skirmish. During this period, in railway regions, a concept of warfare based on speed, accuracy, and the use of armored vehicles emerged, receiving the name the power of the rails. By 1920, the activity of armored train deployment significantly decreased. Collisions between Red Army armored trains and Polish railway compositions were observed along the western borders. These battles on rails are considered among the last of this era. In the areas of Kovel and Radziwiłło, trains engaged in direct fire contact, with success depending on the first accurate shot. Upon the completion of combat operations, railway tracks remained damaged by shell craters, and the hulls of armored trains were covered in soot marks. The post-war period was marked by the withdrawal of some armored trains from service. The others were distributed throughout the country, and some remained on sidings for many years, exposed to the elements. Thus ended the era of these armored units, which played a significant role in military campaigns, influencing the defense of populated areas and the development of frontline operations.